Hello and welcome to our channel where we continue to discover the secrets of the universe. In today's video, we'll talk about a revolutionary new model that helps us understand how massive planets like gas and ice giants form. This model illuminates the complex processes that occur in protoplanetary disks orbiting stars and reveals how these processes form the largest and most mysterious planets in our universe. Understanding planet formation has long been a puzzle for planetary scientists and astronomers. The prevailing theory for many years is known as the accretion theory. This theory proposes that in disks of gas and dust orbiting stars, small particles coalesce to form larger structures. These particles merge together under the influence of gravity to form small celestial bodies called planetesimals. Over time, these planetesimals collide to become larger objects and eventually form planets. But this process can be much more complicated than we think, especially when it comes to gas giants. The existence of ice giants like Uranus and Neptune in the solar system, or the existence of distant gas giants discovered around other stars, seriously challenges the accretion theory. The time required for the formation of such planets seems much longer than the lifetime of protoplanetary disks. Furthermore, how could these planets exist at such great distances from their stars in a much shorter time than the theory predicts? These questions have led scientists to develop more comprehensive and explanatory theories. In recent years, scientists have tried to answer these questions with new mechanisms such as current instability and pebble accretion. Current instability allows particles in gas disks to come together under the influence of drag to form larger structures. This process facilitates the collision of small dust particles and the formation of planetesimals. Pebble accretion, on the other hand, allows centimeter to meter-sized particles to coalesce due to gas resistance and form larger objects. But even these mechanisms cannot fully explain some planet formation processes. This is where a new model comes in. Tommy Chi-Ho Lau from Ludwig Maximilians University and his team have developed a model that can help us better understand the physical processes behind planet formation. This new model is based on structures known as disk substructures found in protoplanetary disks. These substructures are defined as annular distortions, or annular structures that cause dust and gas in the disk to concentrate in certain regions. These structures create migration traps that accelerate and trigger planet formation. These annular distortions allow small, millimeter-sized dust particles to accumulate within the disk. Migration traps prevent these particles from entering the star's gravitational field, trapping them in specific regions. In these regions, the cores of planets form rapidly. When the cores grow large enough, they pull in gas to become massive planets. This process could explain the rapid formation of gas giants near or far from their stars. Powerful telescopes like ALMA, Atacama Large Millimeter Submillimeter Array, are being used to test the accuracy of this new model. ALMA can observe protoplanetary disks around young stars and directly study the process of planet formation. Especially the presence of gas giants beyond 200 AU supports the validity of this model. In the solar system, Jupiter is 5 AU away and Neptune is 30 AU away. Such observations help us better understand the formation of different planetary systems, such as our solar system. The new model also helps explain why planets form in a certain order and in a certain sequence. When the first gas giants form, these planets block the movement of dust and gas in the disk, preserving the material needed for the formation of new planets. This leads to the successive formation of a series of planets. This process can explain the arrangement of planets in a chain, as in the solar system. For example, the gaps between planets and their orbital positions are consistent with this model. The study authors note that this model is the first to show how planetary cores form rapidly and then transform into massive planets through gas gravity. This process explains how both gas giants and ice giants can form in such a short time. However, questions such as how these substructural features arise and how gas is pulled in during the growth of gas giants remain to be answered. Answering these questions requires further development of the theory of planet formation. Future research will focus in particular on the processes of gas gravity and planetary growth. This could help us better understand how planets form, both in our solar system and in other star systems. It could also allow us to discover how the complex interactions that occur during planet formation work and how these processes form different planetary systems. This new model expands our understanding of planet formation and brings us one step closer to one of the universe's greatest mysteries. What are your thoughts? How does this new model affect how you think about the formation of our solar system and other star systems? What do you think about the new discoveries and research? Don't forget to share your comments with us. If you liked our video, please press like and subscribe to our channel for more content. See you in our future videos. Bye.